Hi, my dear students. In today's class of electronic device and circuits, we are going to discuss about uh, transformer coupled amplifier under multistage and feedback amplifiers. See, the agenda of the today's class is we have already the agenda of the today's class is to draw the circuit of a single stage and two stage transformer coupled amplifier and the operation of the transformer coupled amplifier, function of each component of the transformer coupled amplifier, that is a two stage transformer coupled amplifier, and also the frequency response of the transformer coupled amplifier. That is, we will draw the frequency response of the transformer coupled amplifier and also we will explain in detail. So, the revision. Uh, we have already come across the topics of multi-stage amplifiers and the necessity of multi-stage amplifiers. And the function of each component of a practical single-stage transistor amplifier we have discussed. There is a common emitter transistor amplifier with a self bias, that is R1 R2 for providing the self bias, RE is for temperature stabilization, and CE for emitter bypass. Cin is an input capacitor and C is a coupling capacitor for a single stage practical transistor amplifier. And we have also discussed uh, gain, bandwidth, and the frequency response of a multi-stage amplifier. And in the last class, we have come across the RC coupled amplifier, a two-stage RC coupled amplifier working, a function of each component, and frequency response of the same. It is RC coupled amplifier. Okay. Let us see a single stage RC coupled amplifier, which we have discussed in the last class. Just we'll rewind about this yesterday's class. Uh, Here you see the single stage RC coupled amplifier. See here, the input signal is applied here, and Cin is a input capacitor, and it is applied to the base of the common emitter transistor. And here the R1, R2, and RE are the biasing and temperature stabilization resistors. And RC, across the RC, here you get the output. That means whatever the input you apply at the base of this transistor, then there is a voltage developed across the RC, uh, that this voltage across the RC is now the output, which is now given to the RL through CC, that is a coupling capacitor. The purpose of this Cin and CC, we know, which is to isolate the DC condition of the amplifier and to allow only AC. And here the CE is emitter bypass capacitor. Okay, right. So here the CE is the emitter bypass capacitor. Okay. if we apply a small input signal at the base of the transistor, then the output appears at RL, which is of 180 degrees out of phase in a RC coupled amplifier. And let us go to the two-stage RC coupled amplifier. See here. Here we have added one more transistor amplifier, that is cascading. The output of the first stage is connected to the input of the next stage. Here this is the first stage, and here this one is the second stage. These two are now cascaded. Okay, and the output, so we know all the components, that is R and C. So these two combination gives RC coupled amplifier. Okay, why the RC coupled amplifier is called as so means the coupling elements used are resistor and capacitor, that is a collector resistor RC and coupling capacitor CC, so that it is called as a RC coupled amplifier. And now we know R1 R2 are providing the biasing, and C is the inter bypass, and RE for temperature stabilization. And now um, here the output is the output of the first stage. Here the output of the first stage is 180 degrees out of phase here. Okay, as you apply a small input here, the output is 180 degrees out of phase here. So as you are applying this out of phase signal to the base of the second stage, and here you get again 180 degrees phase shift, so that the output will be like this. It is an amplified version of the first input signal, but here it is of 360 degrees out of phase. That means 0 degrees phase shift. Okay, let us go to the frequency response of the RC coupled amplifier. Here the frequency response, okay, at low frequencies and high frequencies it is rolling up. That means the gain is reduced, and at a mid frequency range that we are getting a flat response. So this flat response is uh, in range of audio frequency range. So as it is an audio frequency, that is 50 Hz to 20 kHz, the RC coupled amplifier is used in the audio applications like PA systems. Okay, and now uh, so all we know about this, why the reactance, why the gain of the RC coupled amplifier at low frequencies and high frequencies is reduced, and why it is constant at mid frequencies. All this we discussed in yesterday's class. Okay, and let us directly go to the transformer coupled amplifier. Okay, right. Transformer coupled amplifier. Let us see the circuit diagram of the transformer coupled amplifier first. Okay, a single stage transformer coupled amplifier. How it could be? See, let us see. Okay, if you observe the single stage transformer coupled amplifier here, uh, the R1 R2 R1 R2 R1 R2 are providing the uh, biasing. There is a for self bias, the RE for the temperature stabilization, and C is a emitter bypass capacitor, we know. So here the only difference is instead of RC, instead of RC, that is a collector resistor, we have now using a transformer. That is the primary of the transformer is replacing the RC of this uh, transistor amplifier. And how the output is collected then? So this is we know the function of a transformer, that is a mutual inductance. So the due to the due to mutual inductance, so the secondary winding will get the same voltage here, which is developed across the collector, that is a primary of the transformer. So here the coupling is with the transformer. Here the coupling is with the transformer. So the collector resistor RC and coupling capacitor CC both are replaced with the transformer. That is primary is replacing the RC and secondary is replacing the CC. So that here we are using only a transformer instead of this resistor and capacitor. So it is called as a transformer coupled amplifier. The coupling element used here is a transformer. Okay. And now here you can observe the replacement of the RC with the primary of the transformer. And here the total transformer uh, is shown here. So the second across the secondary we are taking the output. The function of a coupling transformer. What are the functions of a coupling transformer? Of course, almost all we know the coupling element need. So it couples the output of a first stage to the input of the second stage, or directly to the load if it is a single stage. Okay. And now isolates the DC conditions between the stages uh, and provides impedance matching. This is a advantage of a transformer coupled amplifier. Sorry, transformer coupling. So transformer coupling device provides a impedance matching. You know, the two-stage transformer coupled amplifier. A black diagram, how it could be see if you observe the black diagram of the two-stage cascaded amplifier. First stage